Hello. Mm, Today we are going to talk about linear inequalities in one variable. In previous classes, we have already studied solving linear inequalities and problems involving linear inequalities. Now, in this video, we are going to talk about linear inequalities in one variable. Okay. Given two or more linear inequalities which are connected by the word and, the solutions to each inequality must satisfy all the others simultaneously. In other words, only the common solutions of the inequalities should be considered. So in this class, actually, we are going to solve two linear inequalities simultaneously. To do this one, actually, we need to solve the first one and we need to solve the second one. And after that, we need to write their solution sets. And as a solution, we need to choose the common interval, like that interval that contains the solutions of both inequalities at the same time. Here we have some how we illustrate the solution of linear inequalities in one variable on the real number line. For example, if let's say the solution of a given linear inequalities is from A to B at the time, this is A and this is B, it is not including this boundary points, so we are just using parentheses. Or if we have equal sign, A is less than or equal to X, X is less than or equal to B, that means that all the numbers between this A and B on this interval, it satisfies two inequalities given. And how do you show this? Using brackets or rectangular brackets. Okay, and this is half closed, semi-closed from the left hand side. It does not contain this point on the right hand side. Also B is the solution, and this is how we denote actually the solution in set form. And this is just algebraic solution. This one is on the number line, illustrating the solution set on the number line, and this one is using set form. Okay, so let's consider this example. Solve the inequalities. Here, as you see, we are given two inequalities. 3x plus 4 is greater than 13, and 4x minus 13 is less than 11. So we have to solve them together. To solve these inequalities, first we have to solve them separately. The first step, let's say the first inequality is 3x plus 4 is greater than 13, right? And we have already studied and practiced a lot of questions how to solve about solving these kind of inequalities. And just take this 4 to the right hand side. After that, divide both sides by positive 3. Then we will get this solution. X is greater than 13 minus 4. It is 9. 9 is divided by 3. It is 3. Right? So on the number line, here we have 3, not inclusive, right? All the numbers greater than 3 will be solution to this inequality, right? So if you just pick any number from this interval and substitute into this inequality and evaluate this, the result will be greater than 13. So the second inequality is 4x minus 13 is less than 11. And also, if you solve this inequality, we get 11 plus 13, 24, and is divided by 4, that is 6, right? And on the number line, here we have 6, not inclusive. All the numbers to the left of this number will be solution to this inequality, right? Now, as you see here, all the numbers. Now, if we just write or illustrate these solutions on a single number line, here we have 3, and here we have 6, right? Here all the numbers greater than 3, here all the numbers less than 6. So we are talking about this interval, right? All the solutions are here. So in set form, the solution set of this inequality is from 3 to 6. Okay. Next example, find the integer values of x for which. 3x is less than or equal to x plus 6, and 2x plus 4 is less than or equal to 3x plus 6. Here, first we have to solve this, and the question is find the integer values, right? So we need to pick only integer values among all the solutions of this inequality. Again, we follow those steps we just did in the previous example. In the first step, we solve the first inequality. So it is 3x is less than or equal to x plus 6, right? Take x to the left-hand side. Here we have 2x less than or equal to 6. X is less than or equal to 3. In the second step, we need to solve the second inequality. 2x plus 4 is less than 3x plus 6. So it is take to the left hand side 2x minus 3x, that is minus x, less than 6 minus 4, that is 2. So we need to have x alone here to do this one. Let's multiply both sides by -1, and also we need to change the direction of this inequality sign. At the time we have x is greater than, right, x is greater than -2. Okay, so here is our number line. It says from -2, not inclusive, -2, and here we have 3, it is inclusive, right? So the shaded circle. So greater than -2. What numbers are greater than -2? All numbers to the right of -2. And what numbers are less than or equal to 3? All the numbers to the left of 3. So if we just shade this interval, so the solution sets, right, of this inequality is from -2 to 3. But here the question is, we need to find the integer values. So what integer values we have here? Actually, before -2, we have -1, and here we have 0, and here we have 1, and the 2, and 3. So say all the integer values of this, let me just write here, solution of this inequality, then it will be -1, it is 0, 1, 2, 3. That is the answer to this question, right? Because it is asking us to find the integer values. And here on this interval, we have infinitely many real numbers, right? And among this, only we have -1, 0, 1, 2, 3. Only these numbers are integer on this interval. So this is the answer or solution of this problem. Another example, example 11. Find this, solve the following linear inequalities. Step 1, it is for x plus 9 is greater than x plus 5, right? And take to the left-hand side, it is 3x greater than 5 minus 9, it is -4. So x is greater than -4/3. Step 2, we need to solve the second inequality. To x plus 17 is less than or equal to 11. So 2x less than or equal to 11 minus 17 minus 6. So divide by 2, and here we have -3. Okay, so it is greater than this number, less than or equal to this number, right? So if you just draw a number line, first inequality solution here is, here we have, actually let me just, right here we have -3 here, and here we have -4/3. Solution of this one is less than or equal to, right, to the left of this number. So all the numbers here will be solution to this inequality. The second one, the first one, all the numbers greater than -4/3. That is to the right of this number. As you see here, these inequalities, they do not have any intersection area here, right? Or double cross area, let's say. So that means that this Simultaneous inequalities do not have solution. Okay, then what is the solution set? Solution set is empty. It doesn't have any element, doesn't have solution. Okay, because there's no any common area. There's no any number that belongs to this interval at the same time to this interval. Right? That's why the solution has, these inequalities have no solution. Example 12. Here, solve the inequality. It is exactly the same what we did previously, but it's just given in different form. How do we read these inequalities? That is 3x minus 1 is less than x plus 5, and x plus 5 is less than or equal to 4x plus 14. Okay. Actually, to solve this kind of inequalities, we should just write them in, separately. That means I'm just going to pick the first two inequalities, because after reading this, we are saying it and taking the second part, the latter two inequalities. At that time, we will have simultaneous inequalities here. That is 3x minus 1 less than x plus 5. And here we have x plus 5 less than or equal to 4x plus 14. Right? So we have to solve these inequalities, and these two things are equivalent. Okay, this is how we are transforming these inequalities into this form. And now we know how to solve these inequalities. First, if you solve the first one, take x to the left-hand side. That is 3x minus 1. 3x minus 1 is less than x plus 5, right? And take x to the left-hand side. Here we have 2x less than 5 plus 1. That is 6. So x is less than 3. And how about the second inequality? X plus 5 is less than or equal to 4x plus 14, right? And take 4x to the left-hand side. X minus 4x, that is minus 3x, less than or equal to 14 minus 5, that is 9. Or if you just divide both sides by negative 3, and also don't forget to change the direction of this inequality sign. So x will be greater than or equal to negative 3. Okay, less than 3 and greater than or equal to negative 3. So if you just illustrate this on the number line, here we have negative 3 inclusive, right? And here we have 3 not inclusive, right? This is greater than to the right, and this is less than. So between these two numbers. Okay, or in set form, solution of these inequalities would be from negative 3 to 3. Done. The last example, 13. Given that 2x plus 3 is less than 5x plus 2 is less than 3x plus 28. Find, question A, the smallest prime number. What is a prime number? We should know this. X that satisfies the above inequalities. B, the largest prime number x that satisfies the above inequalities. C, the smallest integer x that satisfies the above inequalities. Okay, actually we will do them step by step. To answer these questions, first we have to solve these inequalities. And now we have just learned actually how to solve these inequalities. First we have to transform this into the standard form. That is, first step here we have 2x plus 3 is less than 5x plus 2. And 5x plus 2 is less than or less than 3x plus 28. The first step, we have to solve these inequalities, right? All right, the first part, 2x, 5x to the, take 5x to the left, 2x minus 5x minus 3x less than 2 minus 3, that is negative 1. The second one, take to the left-hand side, 5x minus 3x, that is 2x, less than 28 minus 2, that is 26. Right? Or the first one, we should divide both sides by negative 3. Then we have here x is greater than, because we are dividing by negative 3. Also, we need to change the direction of this inequality sign. Right? Here we have negative 1 over negative 3, that is just 1 over 3. And then second one, x is divided by 2. It is less than 26 over 2. That is 13. Right? Now on the number line, let me just draw in a long number line. Here we have 1 over 3. And here we have 13. Okay. So now we can answer question A. It says the smallest prime number, the smallest prime number, right? And what prime numbers we have here? Actually, on this interval, prime numbers, what are those prime numbers? That is 2, 3, 5, 7, 11, right? We know the prime number is a natural number which has exactly two different divisors or factors. All of these numbers, 2, the factors are 1 and 2, 3, 1 and 3, these are prime numbers. So among these, the question is asking the smallest one. Which one is the smallest one? 2. So the smallest prime number in the solution set is 2. Question B, the largest prime number x that satisfies the above inequalities. All the prime numbers in the solution sets are these numbers, right? So among these prime numbers, which one is the largest one? It is 11. So the answer to question B is, it is 11. C, the smallest integer x that satisfies the above inequalities. Actually, how many integer solutions we have here? And the smallest integer that is greater than 1 over 3 is, what is it? It is 1. Next one is 2. It is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All these actually, these are integer solutions of these inequalities. So among this, it says smallest integer x. So which one is the smallest? It is 1. So the answer to the question is, it is 1. Okay. So all right, that's the end of this lecture. Thank you very much.